So, let's go. You can see 93 billion light years in every direction, and that's the problem. The universe didn't stop there. It just stopped letting you look. What's past the edge isn't empty. It isn't nothing. We just can't know yet. Here are 10 of the most realistic theories about what's actually hiding out there. Number 10. The observable universe is a cage, not a map. Before you go looking for what's beyond the edge, you need to understand what the edge actually is. Because it's not a wall. It's not the end of space. It's not even a place you could visit and stand at and look out from. It's the end of you. More specifically, it's the end of your ability to receive information. Light takes time to travel, that seems obvious. But the consequence of it is genuinely hard to sit with. The light hitting your eyes right now from the most distant galaxies left those galaxies almost 14 billion years ago. Those galaxies existed before our sun, before Earth. Before the solar system had any of the ingredients it needed, that light has been traveling the entire history of everything you've ever known just to reach you right now, in this moment, while you watch this video. But here's the part that breaks your brain. Those galaxies aren't 14 billion light years away, they're about 46.5 billion light years away. Because space itself has been stretching the whole time the light was traveling, the universe expanded underneath the signal like a conveyor belt running in the wrong direction. The light was moving forward, the destination was moving faster. The only reason it reached you at all is because in the early universe, expansion was slower. Slow enough for light to make headway before dark energy kicked in and started pushing everything apart at accelerating speed. So, the observable universe isn't a map of everything that exists. It's a map of everything whose light had time to reach you before your brief window closes. Anything beyond that horizon isn't hidden by distance, it's hidden by time. Its light left long ago. It is on its way. It will never arrive. And here's the part nobody puts in the poster. The cage is shrinking. As dark energy keeps accelerating the expansion, more and more of the universe is crossing into permanent invisibility. Galaxies we can see right now are already on their way out, their light slowly losing the race against the stretching of space. In a few 100 billion years, a civilization sitting in our galaxy would look out at the sky and see almost nothing. No distant galaxies, no evidence of the large-scale structure, just their own local group, marooned in what looks like an empty universe. They'd have no way of knowing any of this ever existed. The evidence will be gone. You are not at the center of the cosmos. You are at the center of a bubble, and the bubble has a leak. Everything beyond it isn't somewhere you can go. It's somewhere the universe has already decided you never get to see. That's the cage. Now, let's talk about what might be inside the walls. Number 9, more of the same. Here's the most scientifically honest answer to what's past the edge. It's also somehow the most unsettling one. Nothing changes. No twist, no reveal. It just keeps going, looking exactly like this, forever. When satellites mapped the oldest light in the universe, the cosmic microwave background, a faint cold glow left over from 380,000 years after the Big Bang, the moment the universe cooled enough for light to travel freely for the first time, they measured something remarkable. They measured the curvature of space itself, the shape of the whole thing. And the number they got was 1, exactly 1. Not 0.99, not 1.01. 1 to the precision of the instruments. Flat, not curved like the surface of a sphere, not curved like a saddle, just flat in every direction as far as physics can measure. Flat geometry means parallel lines never meet. It means the angles of a triangle always add up to exactly 180 degrees. And it means, mathematically, that space can extend forever without contradiction. A flat universe has no reason to end. No geometry requiring a boundary. Just space going on, doing the same thing it does here, everywhere. The cosmological principle, the foundational assumption of modern cosmology, says matter is distributed uniformly at large enough scales. Zoom out far enough and every region of the universe looks like every other region. No special center, no preferred direction, no edge where the galaxies thin out and give way to something else. Just structure repeating in every direction without apparent limit. The consequence of that is the thing nobody talks about at parties. If space is flat and infinite, and matter is distributed according to the same rules everywhere, then every possible arrangement of matter that can exist does exist. Somewhere out there is a galaxy that looks exactly like the Milky Way, orbiting a star that looks exactly like the Sun, on a planet that looks exactly like Earth, with a person sitting in a room that looks exactly like yours. Not similar, identical, down to the quantum state. The first exact copy of your Hubble volume, same galaxies, same stars, same planet, same you, watching this right now, is estimated to be roughly 10 to the power of 10 to the power of 118 meters away. Write that number out and it would fill more books than there are atoms in the observable universe, but in an infinite flat space, that distance means nothing. Distance doesn't run out. The copy exists. It has always existed. It is living your life right now, at this exact moment, having just read that sentence. You wanted something strange past the edge. Turns out the strangest thing out there is more of you. Everything from here gets less certain. That last section was the physics that's actually settled. Measurements, geometry, the standard cosmological model. What comes next is where the ground starts to shift. Real science, but science at its edges. Keep that in mind. Number 8, the quantum copy problem. The infinite copies thing isn't just a fun thought experiment, it's a mathematical obligation. And once you understand the mechanism behind it, it stops feeling philosophical and starts feeling deeply personal. Every object in the universe can only be arranged in a finite number of ways. Not infinite. Finite. There's a hard ceiling on the amount of information you can pack into any given region of space before it becomes so dense it collapses into a black hole. That ceiling is set by the Bekenstein bound, a limit that ties information content to the surface area of the region containing it. Your brain has a maximum number of possible states. The room you're sitting in has a maximum number of possible states. The entire observable universe has a maximum number of possible states. That number is incomprehensibly large, but it's a number. And in an infinite universe, a finite number of configurations means infinite repetitions. Every arrangement repeats. It has to. The same logic that says a deck of cards shuffled randomly and infinitely will eventually produce every possible ordering, including the one it started with, including any specific ordering you name, applies to the arrangement of matter in space. But here's where it stops being abstract and starts being about you specifically. Your exact quantum state right now, every particle in your body, every electrochemical signal in your brain, every memory encoded in your neural architecture, the exact configuration of every atom, is one of those finite configurations. And in infinite space, it repeats. Your copy out there didn't just happen to end up in the same state by coincidence. They share your entire history, same formation of the same star, same geology on the same planet, same evolutionary path, same parents, same childhood, same decisions, every single one, right up until the quantum randomness of the universe caused the paths to diverge, a cosmic ray hitting a neuron slightly differently, a single particle decaying a fraction of a second earlier, the butterfly effect taking two identical histories and splitting them apart at the subatomic level. They don't know you exist. You can't know they exist. You can't communicate. You can't reach them. You can't even point in their direction because the distance is so far beyond the observable horizon that the concept of direction loses meaning. But the math says they're out there. Not as a metaphor for human similarity or a poetic observation about shared experience, as a physical fact derivable from a flat infinite universe and the information limits of quantum mechanics. Right now, your copy is making a different choice, has made different choices, is living a version of your life that branched off somewhere you can't identify in a direction you'll never see. The universe doesn't just permit that, it requires it. Number 7. The universe is shaped like a hall of mirrors. Here's something that gets glossed over in almost every explainer about the shape of the universe. Flat doesn't mean infinite, it means the geometry is flat. The topology, the actual shape of the space, how it's connected to itself, is an entirely separate question and it leads somewhere genuinely strange. Think about a video game that wraps around. You walk far enough to the right, you come out on the left side. Nothing about the game feels curved. The physics inside it are perfectly flat. But the space isn't infinite, it loops. The surface of a donut mathematically is flat. No curvature. A triangle drawn on it has angles that add up to 180 degrees. But it's finite. It has a size. And if you travel far enough in one direction, you return to where you started without ever hitting a wall. Cosmic topology asks whether our universe does the same thing, whether space, despite being geometrically flat, folds back on itself in some higher dimensional shape we can't perceive from inside. A three-dimensional torus. A more exotic shape called a Picard horn, which is flat and infinite in some directions but finite in others. There are a handful of candidates. Each one would produce a universe that looks infinite from inside but has a finite amount of space in it. If it's true, then the observable universe might be showing us the same regions over and over again, from different angles, at different times. That galaxy we cataloged as unique, billions of light years away, might be the Milky Way. Not a twin, not a copy. The actual Milky Way, seen from the far side of a loop, from a time before the sun existed. We could be staring at our own past and filing it under a different name. There's a test. If space loops back within the range of what we can observe, the cosmic microwave background should show matching circles, pairs of temperature patterns, identical to each other, stamped in different parts of the sky like reflections. The same cosmic structure, seen twice from different angles. Scientists ran the search. For every possible axis and scale, they looked for matched circles in the Planck satellite data. They didn't find them, not at the scales that would put the repeat distance within our observable range. But that only rules out a universe that wraps around close enough for us to see the repetition. A universe that loops back just beyond the horizon, just out of reach, just one step too large for the pattern to show up in our data, is still completely viable. The Hall of Mirrors might exist, we'd just be standing slightly too close to the center to see the reflections. Number 6. The bubble we live in. Now the ground shifts more seriously. This is where the theories stop being about the shape of the universe and start being about what the universe is sitting inside. The leading model for what happened in the first moments after the Big Bang is called cosmic inflation. It says that a fraction of a second after the beginning, a fraction so small it doesn't have a name in ordinary language, the universe went through a phase of expansion so violent it makes everything that came after look like stillness. A region smaller than a proton stretched to the size of a grapefruit, then a basketball, then something the size of the observable universe, all in less time than light takes to cross an atom. That expansion smoothed out the geometry, flattened the curvature, distributed matter evenly. It explains almost everything about why the universe looks the way it does. But inflation, in its most theoretically natural form, doesn't stop everywhere at the same time. The field driving it, a kind of energy built into space itself called the inflaton, decays unevenly. Some regions settle down. They stop inflating, cool, and collapse into what you might call pockets of normal physics. Those pockets expand, structure forms inside them, stars ignite, galaxies assemble. From inside one of those pockets, the physics looks stable. The rules are consistent. Everything behaves. We live in one of those pockets, a bubble. Our entire observable universe, every galaxy, every quasar, every photon that has ever reached a human eye, fits inside one nucleation event in a still inflating sea. The space outside our bubble isn't a vacuum waiting to be filled. It's chaos. Inflation's still raging at near light speed in every direction. New bubbles constantly nucleating inside it, each one a potential universe, each one sealed off from the others by the expansion of the space between them. The bubbles grow, but the gaps grow faster. Our bubble will never touch another one. The outside is not accessible by any means, not travel, not signal, not in principle. The horizon around our observable universe isn't just a visibility limit, it might be a phase boundary. The edge of the pocket where our physics stabilized. Step outside it if you could, and you wouldn't be in empty space. You'd be in a region where the vacuum hasn't settled, where the rules are still shaking out, where nothing we know about matter or energy or time applies in any recognizable way. The horizon isn't a distance, it's a door. And it opens onto something that isn't space the way you understand space at all. Number 5, the bubble next door. Here's where it gets testable. And here's where it gets personal. Because if this one is right, we're already carrying the evidence in the oldest light in the sky. If other bubbles exist, and the eternal inflation model says they must constantly, an incomprehensible number of them, then some of them nucleated close enough to ours early enough that their expanding walls could have intersected with ours before the space between them inflated out of reach. A bubble collision. Two regions of space running different vacuums slamming into each other at a significant fraction of the speed of light. Our bubble survived, obviously. But a collision like that doesn't leave nothing behind. It leaves a mark, and the mark is specific enough to look for. The predicted signature is a disc-shaped region of the cosmic microwave background where the temperature is off. Not randomly off, geometrically off. A circle on the sky, colder or warmer than its surroundings, caused by energy that got dumped into our universe at the contact point when the two bubble walls met. The shape matters because a collision between expanding spheres always produces a circular intersection. If you see a random blob, that's something else. If you see a clean circular anomaly in the oldest light in the universe, that might be a scar from a universe hitting ours. The CMB cold spot has been sitting in the data for years. A region about 8 degrees across, and that's 16 times the width of the full moon, measurably and consistently colder than the surrounding sky. It's been examined from every angle. Statistical artifact, some say. Supervoid in the foreground, others argue a vast empty region that cooled the photons passing through it. But the supervoid explanation requires a structure so large it strains the cosmological models that predict how large structures can get. The cold spot hasn't been explained away. It also hasn't been confirmed as anything exotic. It just sits there, cold, circular, waiting. If it's a collision scar, it's the most profound object in human history. Direct physical evidence that another reality existed, touched ours, transferred energy across the boundary, and kept expanding. Whatever physics ran inside that other bubble, whatever particles it had, whatever forces held its matter together, whatever its constants were, all of that pressed against the edge of our universe and left a bruise. We might be looking at it every time we see a map of the CMB and wonder what that cold smudge is. Number 4. The dark flow and the thing. Pulling everything. Something is pulling the universe sideways. Not everything. Not randomly. Coherently. Directionally. In a way that shouldn't be possible if the universe is as uniform as our models say it is. When you measure how galaxy clusters move through space and subtract out the expansion of the universe itself, what's left is called peculiar velocity. Each cluster's own motion, independent of the stretching of space. In a perfectly uniform universe, peculiar velocities should point in random directions. No pattern. Just local gravitational influences pulling things toward nearby mass. What surveys found instead is that hundreds of galaxy clusters spread across enormous stretches of sky are all drifting in roughly the same direction, toward a region near the constellations Centaurus and Vela. Not all of them, not perfectly, but the signal is there. A coherent bulk motion called dark flow, like a current in water that's too large and too consistent to be explained by anything visible in our maps. Part of it is the Vela supercluster, a massive concentration of galaxies that was only mapped in 2017 because the Milky Way's own dust had been blocking the view the whole time. It's enormous, and its gravity is real, and it accounts for some of the drift. But some researchers argue the pull extends well beyond what Vela can explain, out to scales where nothing in the observable universe should be able to generate that kind of sustained gravitational influence. The explanation that hasn't been ruled out is a structure passed to the horizon, something so massive that it formed before inflation smoothed everything out, a density knot from the earliest moments of the universe, a place where matter clumped up before the Big Bang's fireball had a chance to homogenize everything. Inflation diluted almost everything. But almost isn't everything. If something was dense enough, old enough, and large enough, its gravity could still be reaching across the horizon right now, tugging at everything in our universe the way the moon tugs at the ocean. Quietly. Constantly. Without ever showing us its face. We can't see it, we can't measure it directly, we can't point a telescope at it. But we might be feeling it right now. Every galaxy in the local universe nudged, every cluster drifting towards something that exists entirely outside the boundary of what we are permitted to observe. Number 3, the other side of the Big Bang. What if the horizon isn't a boundary in space at all? What if it's a boundary in time? The standard model of cosmology treats the Big Bang as the beginning. Time, 0, the moment before which the question doesn't apply. But some physicists think that's not right, that the Big Bang wasn't the start of everything, but a transition, the middle of something larger. And what's past the edge of our universe might not be a different place, it might be a different time, one we can't access because a wall of fire stands between us and it. In loop quantum cosmology, the universe bounced. A previous universe collapsed under its own gravity, contracting, getting denser, hotter, more compressed, and instead of reaching a singularity where physics breaks down, quantum effects reversed the collapse. The universe tunneled through its own end and came out the other side expanding. Our Big Bang was someone else's big crunch. The universe before ours didn't die, it became us. It is us. In conformal cyclic cosmology, developed by physicist Roger Penrose, the logic is different, but the conclusion rhymes. At the very end of a universe's life, after all the black holes have evaporated, after all the matter is decayed, after nothing is left but photons drifting in a cooling void, time itself becomes meaningless. Photons don't experience time. In a universe containing only light, the geometry of the dying end and the geometry of a new Big Bang become mathematically identical. One universe's death is another's birth, and Penrose argues the previous cycle left marks, faint circular patterns in the CMB called Hawking points, the last whispers of the black holes that evaporated at the end of the universe before ours. Some researchers think they found those points, others dispute the statistics. The debate is ongoing. But the idea is serious enough that it's published, tested, and argued about by physicists at major universities. Not dismissed, not confirmed, just open. If any version of this is right, then what's past the edge of the observable universe isn't just more space. On the other side of the beginning, there's an entire cosmos that lived and died to become ours. Billions of years of stars and galaxies and structure and possibly life. All of it compressed into a signal we might be misreading as background noise. The universe before ours isn't somewhere out there. It's underneath us. It's the floor we're standing on. Number 2. The multiverse with different physics. The bubble universe picture assumes other bubbles exist. String theory takes that premise and multiplies it by a number so large it makes infinity look manageable. And it adds something the bubble picture alone doesn't. The other universes aren't just different locations, they're running different software. The mathematics of string theory doesn't produce one unique universe. It produces a landscape of solutions, roughly 10 to the 500th power of them, each corresponding to a possible universe with its own physical constants, its own strength of gravity, its own mass for the electron, its own value for the cosmological constant that determines how fast space expands. Each one is mathematically valid. Each one, if it exists, is a complete cosmos with its own version of physics. Most of them are dead. In a universe where the strong nuclear force is slightly weaker, protons don't hold together and atoms never form. In a universe where the cosmological constant is slightly larger, space expands so fast after the Big Bang that matter never has time to clump into galaxies or stars. In a universe where the electron is slightly heavier, chemistry doesn't work. The constants we have, the specific numbers that make our physics possible, are extraordinarily finely tuned for complexity to exist. Change almost any of them by even a small amount, and you get a universe full of nothing interesting, lasting a fraction of a second, noticed by no one. The multiverse explanation for this fine-tuning is uncomfortable, but logically clean. If all possible universes exist and almost all of them are hostile to life, then any observer, any being capable of asking why their universe's constants are the way they are, is necessarily in one of the rare universes where the constants work. You can't ask the question from a universe that never produced anyone to ask it. The question filters for the answer. The universe looks designed because you can only exist in a universe that looks designed. In 1987, physicist Steven Weinberg used this logic to predict the value of the cosmological constant before it had been measured. He argued that in a multiverse of varying constants, the cosmological constant in any inhabited universe couldn't be much larger than a certain value, because too large and galaxies never form. His prediction was specific. 11 years later, When astronomers actually measured how fast the universe's expansion is accelerating, the number they got matched what Weinberg had predicted. Not exactly, but within the range he said it had to be in. That's not proof of a multiverse, but it's a prediction made from first principles that landed. In science, that's not nothing. Number 1, the simulation boundary. Every theory so far has assumed that space is a real physical thing, that the universe exists independently, that matter and energy and the laws governing them are fundamental. This last one doesn't make that assumption. And the frightening part isn't the idea itself. The frightening part is that it's testable. If the universe is computational, if it's running on some substrate we can't access, some deeper layer of reality that processes information and outputs what we experience as physics, then the observable horizon might not be a physical boundary. It might be a render distance. The universe generating detail where observation demands it and leaving everything else in a kind of undefined state until something interacts with it. The edge of what we can see might be the edge of what's been rendered. Past it, not empty space, not other galaxies, not anything. Just unprocessed potential, waiting for a query that will never come from inside the system. This sounds like metaphysics dressed up as science. Here's the part that isn't. If space-time is discrete, built from indivisible minimum units at the Planck scale, 1.6 times 10 to the negative 35 meters, below which distance has no meaning, then space is, in a precise technical sense, a grid. And grids have artifacts. A computation running on a discrete lattice doesn't treat all directions equally. It has preferred axes built into its structure. And that anisotropy, that directional unevenness baked into the fabric of space, should show up in the highest energy particles in the universe. Ultra-high energy cosmic rays slamming into our atmosphere from deep space with energies that dwarf anything a particle accelerator can produce should show a faint directional bias if spacetime has a lattice structure. They should arrive slightly more often from certain directions, not because the sources are in those directions, but because the grid they traveled through treated those directions differently. Cosmic ray observatories have found faint directional patterns, not confirmed, not clean enough to claim anything, but not zero. The signal is exactly where it would need to be consistent with the hypothesis and not yet ruled out by the data. The honest version of this theory isn't we live in a simulation, it's if spacetime has a minimum size and that minimum size forms a grid, we should be able to detect the artifacts of that grid in the highest energy particles we can observe. And we are looking. Right now. With real instruments pointed at the real sky, every instrument we've ever built points outward. Every theory on this list has been about something out there. More space, more universes, more physics, more time. But this one points inward. The limit of what we can see might not be a property of the universe. It might be a property of us, of the resolution we're permitted, of the detail the system bothers to render for observers of our scale and our energy and our brief and flickering attention. The cage has no outside. The cage might be the rendering engine. And whatever is running this, if anything is, almost certainly didn't put a label on the wall where the observable universe ends. It didn't need to. It knew we'd never be able to reach it anyway.